Welcome to Global Topic. Today's discussion will be on field joint coatings for pipelines. And joining me today is Koen Klooster from Selmers USA. Koen, welcome.
Hey, hi Jim. Yeah, thank you, and appreciate you having me on your show.
If you could do a favor, if you could cover your professional background and also what Selmers USA does.
hmm Well, my career and my background started with Selmers. I started my career there. I started out in their global service department, and then later on moved to project management. And then 2 years ago, my wife and I moved from Amsterdam, which is where Selmers is based in the Netherlands, to Houston to open the branch office, the Selmers branch office here in the US. So that's where Selmers USA is based. And what Selmers does, and what we've been doing for a long time, is design, manufacture, and install pipe surface treatment and coating plants and equipment. We do this for a very broad range, offshore and onshore, internal and external, for very small diameters, for a few inches, all the way up to 160 inches. And it goes from very small to like big enough to drive a small truck through it. And also very different coatings: epoxy, insulation, concrete mortar, concrete weight coating. It's a very broad range. So if it's pipe coating related or cleaning, we probably have done it in the past. So that's what we do, and that's what I do as well.
Well, when you mentioned it, talking about small diameter pipe all the way to large diameter pipe, where you're able to drive vehicles through it. So Koen, let's focus on when it comes to the assessment and the surface preparation, prior to the field joint coating. Could you cover typically what assessment's done with the pipeline joint, and then what typically surface preparation is performed prior to that field joint coatings?
Yeah, sure. Yeah, and also I didn't mention before, but in the list, but field joint coatings is also one of the things we do. And I think with a field joint, you have to look out for, I think, 5 major things. You want to make sure that the factory coating is in good condition. You need a clean pipe. You need a proper anchor profile. The surface needs to be dry, and it needs to be heated. And blasting will get you a clean pipe and that anchor profile. And there's different levels of cleanliness, but in general, you don't want any corrosion on there, no oils, other contamination, and ideally no chlorides. And then the anchor profile, or the surface roughness, is then the peaks and valley profile in the steel surface, which is also very important for your coating, because if these peaks and valleys are not high and low enough, you don't have enough surface for the coating to adhere to. And then if they're too big and too low, then the coating has trouble getting all the way down in that valley and leave a pocket in there. And if the peaks are too high, it can stick through the coating, and then you have a holiday. So with blasting, you want to get that sweet spot somewhere in between there. It also depends on the type of coating and the application you're doing. But that's the blasting. And then the other surface treatment, which is important, is the heating. So you get the pipe dry, no moisture on the pipe, and you want to get it to a certain temperature, which depends on the coating that you need to apply. Yeah, I think that's it.
Earlier before our conversation here, I had the chance to take a look at induction heating, and I learned a lot more information.
Mm-hmm.
I thought I knew everything about it, but I really don't. I know just a small fraction of it. But with induction heating, what does the process look like, and what are some of the challenges and advantages of induction heating?
Mm-hmm. Well, the process starts by placing a coil around the pipe, usually like 2 half moons or 2 shells. They clamp around the pipe, and then with an alternating current, you create an electromagnetic field in that coil. And what that does, it creates that magnetic field creates currents in the steel surface of the pipe. And these currents are called eddy currents. And as these currents move through the pipe, they meet with a resistance from the material, which creates friction, like when you rub. Very simple, but like when you rub your hands together, you feel how it gets warmer. That kind of friction. So that's what actually, that friction from the material to the currents, is what creates the heat. And then you do that for as long as you need to get that pipe to that set temperature. And like for FB, for instance, that's roughly around the 350, 480 Fahrenheit mark, somewhere in that range. And so it's quite a quick process, and that's one of the advantages. There's also disadvantages. The equipment is more complex. Like if you compare it to a gas burner, for instance, it's more complex. So you need a higher skill level to maintain it and to troubleshoot it if you run into any issues. Another one is like I think it has a higher upfront investment. The equipment itself is more expensive than a gas burner. And another one of the issues that you could have is if you have a large range of diameters of pipe that you're working with, you need a lot of different coils, because induction heating, when the range or the distance between your pipe surface and the coil becomes bigger, it loses efficiency very fast. There's like small range where it has maximum efficiency. So if you have a large range of pipes, you need a lot of different coils. But there's a lot of advantages to it too. Like one of it was the speed. Also compared to like a gas burner, it's a lot faster, and that's important when you're in the field. You want to get the job done as fast as possible, and all the time you can shave off has an impact on your project. So that's a big one. You have no gas or flames, which could be said to be safer, and then also you don't have to store all those gas balls in the field, or if you're on a lay barge, you don't need those there. So that makes it easier. So we have faster. We don't have the open flame and gas. It's also more controlled. You get a more even spread because of the design of the coil. That does impact it, but in general, you get more even temperature over the circumference of the pipe. While with gas, you have differences in different areas of the surface. So it's more even, it's more consistent. And also because of you have a coil, the bandwidth of what you heat, where you heat the pipe is very controlled, and that limits the risk of damaging the field joint coating. Because if you heat that up too much, you damage that, and then you already start you start with an issue. So I think that's it. It's faster, it's potentially it's safer, and it's more controlled, so less risk for damage. Yep, I think that's it.
So in the earlier in your covering of the topic with induction heating, you mentioned about fusion bonded epoxy FBEs, are heavily used, obviously, but in relation to the field joint coating systems like an FBE, how is it applied on the pipeline on the field joints?
So the FBE, the epoxy powder is applied to the pipe with electrostatic guns. The electrostatic part of that helps with the adhesion of the powder to the pipe, and these guns are generally mounted into a frame that's lowered over the pipe, and then there's a mechanism in there that rotates the row of guns along the pipe to create that even coat. And the powder is fed to the guns from a fluidized bed, and what that is basically, if you put it very simple, a box filled with epoxy powder, and at the bottom you have a perforated plate. And through that perforated plate, air is fed in and through the epoxy powder, which makes it behave like a fluid. There's actually, I watched it again yesterday. There's a very interesting video on YouTube about a fluidized bed. It's a guy that turned his hot tub into a fluidized bed, and then he filled it with sand. And one of the experiments he does, he throws a bowling ball into it, and you expect it to sit on top and maybe sink slowly, but it just disappears. It really behaves like it's a liquid, and I can highly recommend it. It's a very popular video. I think when I watched it last night, it had over 80 million views.
Wow!
And if you look for it, if you search on YouTube for fluidized bed, it will probably be at the top. But I can highly recommend it. It's really interesting to see what that process does to a powder. It really behaves like a liquid. It's a really cool trick. Anyway, FBE coating. So the powder, it behaves like a liquid, which means you can pump it now. So you can pump it from your fluidized bed through the guns onto the pipe. And FBE, it's basically a thermosetting epoxy resin, and the other part of that is a curing agent. And the reaction between the two is incomplete. But when it hits that warm pipe and with that heat, it completes the reaction. It starts to melt. You get cross-linking, and then it starts to gel and cure, which gives you that that coating, that characteristically green coating that probably a lot of us know and recognize. Yeah, and that's the process.
Yeah, very, very interesting, both with the technology, equipment, the process that has to be employed, and then obviously with the coating system, there's a lot of things that have to be really special attention needs to be made just to get it perfectly right. You know, we've covered a lot of really great information here. I know there's a lot more we could have really unpacked, and it's probably spent an hour or two or longer on this. You know, in closing out, is there anything that we did not cover that you'd want to leave with the viewers of this episode?
Well, not so much about the equipment, but I think one thing I'd like to mention is, like, in general, I think the field joint coating is considered to be a weak spot in a pipeline, and there is a performance gap between factory coating and field joint coating. And I read recently again that NAE said that they think, and what they see is that improper or insufficient surface treatment is one of the major causes for these failures and for that performance gap. But FB coating has been around for a long time. I think the first time it was applied was 1960, and for that time the coating itself has been the material has been improved, and the equipment has greatly improved. These days there's a lot of high-end, high-tech solutions out there by a lot of great companies. There's a lot can be done with automation, improving that speed and getting that consistency again and again in all those coating, all those hundreds in coating field joints. And another option is combining, like you can have one piece of equipment for the heating with the induction, another one for the coating. There's also ways to combine it in one piece of equipment that eliminates a switch. It eliminates room for error. It's faster. It gives the pipe less time to lose heat. Again, getting into that consistency and that speed. So I think what I want to say is there's a lot of options out there. A lot of people keep developing them, both material and the equipment. And I think I'd like to challenge everybody to take a look what's out there, because I think there's a lot of opportunities to increase that quality and bridge that gap. And ideally, I'd like to see that disappear, both with the equipment and technology out there. Yeah.
Very good. I think you've done an awesome job explaining everything, and I think also too you probably piqued attention to a lot of people. What I'm going to do, Koen, I'm going to make sure that I do put the link to the Selmers website. Yeah. Also, I'll put a link for your professional profile on LinkedIn for those who would want to connect with you professionally. Koen, thank you so much for this opportunity. I really appreciate it today.
Yeah, I thank you too. And like I said, I appreciate being on the show. And if anybody has any questions, they can feel free to reach out to me. I'll be happy to answer any questions. Thank you.
Yeah, excellent. Hey, have a great day.
Yeah, you too. Bye.